Okay, thank you very much for coming back to our channel. My name is Clinton Piqui, and today we are going to be looking at how to solve the Cauchy-Euler differential equation. Now, on the board we have any equation of the form ax squared y prime prime plus bx y prime plus cy equal to some g of x. That equation is called a Cauchy-Euler differential equation. So what is the general uh, idea to represent a Cauchy-Euler differential equation? Look at each term. The power of x and the derivative have the same power for each term. So here you have x squared and you have the second derivative. You have x and you have the first derivative. And then you have no value of x. So we say x in this case, x is 0. The power of x is 0. So what do you have? You have c, which is a constant, and then multiplied by the 0 derivative, which is the function itself, equal to some g of x. That's how you identify a Cauchy-Euler differential equation. Now, when g of x is 0, meaning when the right hand side of this equation is 0, you will call that equation a homogeneous Cauchy-Euler differential equation. But if g of x is some function of x, then that becomes a non-homogeneous Cauchy-Euler differential equation. So let's move on to find the solution to this problem. Solve the DE x squared y prime prime plus xy prime minus y equal to 0. Now, the Cauchy-Euler differential equation, especially for this form of the Cauchy-Euler differential equation, you will assume a solution of the form y is equals to x raised to the power m. So you assume a solution of this form, and then you will differentiate this function based on the number of derivatives within the differential equation, and then you will substitute the result. But notice that for the Cauchy-Euler differential equation, it is not only the second derivative. You can have the third derivative, fourth derivative, up to the nth derivative. But keep in mind that for each derivative, the power of x and the derivative will be equal in terms of the product. Okay, so we differentiate and then we go on. So y is equal to x to the power m. Y prime will be equal to m x to the m minus 1. We use the power rule. And then y prime prime will be equal to m multiplied by, so this multiplied by m minus 1 x to the power m minus 2. Find the second derivative. Now after this, we are going to substitute these three values into this differential equation. So in the case, we have the differential equation is x squared y prime prime plus x y prime minus y is equal to 0. So x squared remains as it is, x squared. And then ask ourselves, what is y prime prime? It's m, so we use bracket here. X squared multiplied by m times m minus 1 x to the power m minus 2 equals this, plus x multiplied by the first derivative is m x to the power m minus 1 equals this, minus y. And what is y? Y is x to the power m is equal to 0. So you replace all of these derivatives within the respective, or for the respective values, and then you simplify the result. So every time you substitute the values of the derivatives into the Cauchy-Euler differential equation, you observe that the power of x and that of this power will cancel because we are multiplying x to the power 2 times x to the power m minus 2. Positive 2 and negative 2 goes out. So you have m times m minus 1 x to the power m plus a very simple thing happens here. So you have x to the power 1 and then m minus 1. So this minus 1 and this positive 1 is going to cancel. We have m x to the power m minus 1 minus x to the power m is equal to 0. Once we have that, we can divide each term by x to the power m, because we have, so sorry, this shouldn't be x to the power m minus 1, because this and this will go up. So we have x to the power m only. So we can divide this term by x to the power m, divide this term by x to the power m, and divide this term by x to the power m. So what do we have? Then this is going to cancel. We're going to have m times m minus 1 plus m minus 1 is equal to 0. So once we have that, we can simplify this equation. So m times m is m squared. So you have m squared there. M times -1 is -m plus m minus 1 is equal to 0. And after we have that, we can simplify. So you understand that what happens here is that -m and positive m is going to cancel out. So we just have m squared minus 1 is equal to 0. Once you have m squared minus 1 equals 0, you can factorize. So we have m plus 1, m minus 1 is equal to 0. And then we use the zero product property. M plus 1 equals 0, m minus 1 equals 0. In which case, m is equal to positive 1, or this is -1. So we send this one across, it becomes -1. And then m is equal to 1. So the two solutions for the quadratic equation we have are -1 and +1. But we assume a solution of the form y equals x to the power m. So finally, we will have y is equal to x to the power m. But notice I'll get two m value. So we have the first value for y1. y1 is equal to, there will always be a constant multiple multiplied by this. So you have c1 x to the power m is -1. And then you have y2 to be c2 x to the power, the value of m in this case is 1. So x to the power 1. Now, these are both solutions to this differential equation. So I'm going to write a general solution by writing these two solutions as linear combination. So we have y is equal to the first one, which is y1 plus y2. So finally, the solution to this Cauchy-Euler differential equation is y is equal to, what is y1? c1 x to the power -1 plus y2 is c2 x. This is the solution, general solution. This is the general solution to this differential equation. If we want to find a particular solution, we could find an initial value and then we'll solve an initial value problem. So thank you very much for watching, and we hope the video is not too long, but hope to see you in our next video. Thank you and God bless.